Alright, so we can switch it from, like I said, log form to exponential form to log form. Because of this rule, we know that a log is actually an exponent. Exponent rules can be applied to logs then. So those exponent rules that we're going to talk about that can be applied to logs is, the first one, if I am multiplying things at the same basis, I can add their exponents. Same sort of thing with logs at the same basis. If I have logs at the same basis, I can multiply what I'm adding here. So it's a little bit different than the exponent. The exponent, I was multiplying. Same base, I added their exponents. With the logs, I have logs at the same base and I'm adding. I'm going to multiply what I was taking the log of before into one log. Alright? It's going to be confusing right now when we go through it like this with all variables in there. When we start doing some problems, I hope it'll make a little more sense. Alright? So the log product is equal to the sum of the logs. We can go either way. We can go from multiplying in here to splitting it up to addition, or having it split from addition to multiplying. Expanding to condensing, or condensing to expanding. So, division then with logs. Right? I have division here, turns into subtraction. Same thing, if I have division in my log, I can split it up into two different logs and I can subtract them. So log division is turned into the difference of logs, or subtracting logs. Then lastly, log base to a power turns into the power times the log. So this one's a little more different than the exponent rule. But what's going to happen is if I have something to a power in my log, I can take that exponent and put it out in front of my log and make it multiplication. Like I said, with the variables, it is a little bit tougher to look at and just understand it. When we do some examples, hopefully it'll make sense. Okay? Do you have any questions as of now? Alright, then let's try some examples. So, anytime it wants us to write an expanded form, we need to separate them as much as possible. So you're going to see things that are in multiplication, division, and exponents. We need to separate them as much as possible. So I have log of 5 times x times y. We said if I have multiplication, I can turn each one of these pieces into addition. Right? That's what we said with our rule back here. We said if we have a multiplication inside our log, we can separate them into different logs and add them. So let's do that. I have log 5 times x times y. I'm going to separate all of them. It becomes log of 5 plus log of x plus log of y. Does that make sense? So if I have multiplication inside my log, I can split up each piece into different logs and I can turn it into addition. Any questions? So the next thing, I'm just going to look and see, do I have any more multiplication, exponents, or division in there? No. So that's my final answer then. That is completely expanded. The next one's a little trickier. The natural log of 2 times x cubed. Do I have multiplication or division? Which one? Multiplication. I have 2 times x cubed. So I'm going to separate those into their own natural logs and turn into addition. So the natural log of 2 times the natural log of x cubed. Right? Separate that multiplication into addition. Does that make sense? So we said anytime I have multiplication here, 2 times x cubed, split it up into their own natural logs. Oh, this should be addition. Sorry. Plus ln of x cubed. Yes, Tobias?
Can I see what I got?
Hold on. We'll get there. Okay? So does that make more sense? Is that why we were confused? Okay. Now, do I have any other multiplication or division? No, not as it looks, right? Do I have an exponent though?
Yes.
Yes, notice we said with exponents, if I have an exponent, I can take that exponent and I can pull it out in front of the log. So in this case, I have the natural log of x cubed. I can take my exponent and put it out in front. So it's going to become the natural log of 2 plus 3 times the natural log of x. And now I'm done. It's expanded as much as possible. I don't need to worry about it. Okay? Does that make sense? Ish?
Wait, why does a 3 go in there?
Because anytime I have an exponent, my exponent turns into multiplication out in front. Okay? Let's look at C. Log base 6 of 3x over y. Okay? Well, I have division. I'm going to start with that. Division turns into what? Subtraction. So what's going to happen is I'm going to get log base 6. Do not lose that base 6. The first two were easier to keep with because I didn't have a base. What would my base have been in the first problem? 10. When there's no base, it's a common, right? So log base 6 of the top minus log base 6 of the bottom. Why? Make sure when we have division, it is always the top minus the bottom. Do not put log base 6 of y minus log base 6 of 3x. Two totally different things. Alright? Am I done here? Why not, Anna?
Because 3x.
Because 3 times x. I can split that up, right? So what I'm going to do is I'm going to put that in parentheses because I know if I condense it, I want to do that first. So it's going to be log base 6 of 3 plus log base 6 of x. Like I said, that's in parentheses because I know I want that to happen before the subtraction or the division. And then minus log base 6 of y. Is there anything else I can do to expand it more? Is there? Multiplication, division? Exponents? No, so I'm done. That's my final answer. Any questions on that? Alright. Let's try and work the opposite way now. So we're going to skip the you tries. We'll come back if we have time. Oh, they're next time. Alright, so now let's try and write it in condensed form. So we have it, it's all expanded out. Now we need to combine it back together. So log of x plus log of y minus 2 times log of z. What's one thing we notice right away? What can I do? Liam?
Separate the log. So it's like log times. Like take out the log.
Take out the log from it. So,
Yeah.
so how would I write it?
Like log times, or log parentheses.
Log
Parentheses. X, y, over.
Okay, so I'm going to leave it like that. I have addition here. I know when I have addition, if I want to condense it, it's going to turn into multiplication. So I'm going to take log and then x times y. Alright? Then minus. What can I do with this number out front here? Make it into an exponent, right? I can put it as an exponent on that z. So minus log of z squared. Alright? So good, we turn our addition into multiplication. We turn our multiplication out here into an exponent. What can I do with that subtraction? Turn it into division, right? So it's going to become log of x times y over z squared. Remember, this first part's going to be my numerator minus the second part, my denominator, so xy over z squared. Can I do anything else to it? No, so that's it. Okay? Next one, natural log of 5 minus natural log 8 plus natural log of x. I'm going to do in the parentheses first. I have addition in there, so what does that turn into?
Multiplication.
Multiplication, so I get natural log of 5 minus the natural log of 8x. Right? Did that in here first. Addition turns into multiplication. Then, I have the natural log of 5 minus natural log of 8x. So subtraction turns into division. So I get 5 as my numerator. So natural log of 5 divided by 8x is my denominator. That's as far as I can go. Alright? So then C, 3 times log base 2 of x plus 4 times log base 2 of y. What's the first thing we notice we can do? Liam.
Turn the numbers in front into x.
Turn the numbers in front into exponents. So it becomes log base 2 of x cubed plus log base 2 of y to the 4th. Awesome. Turn those numbers up front into exponents. Then what should I do? Kuji.
Multiply because they're separated by addition.
So we're adding them, so we are going to multiply log base 2 x cubed y to the 4th. And that's as far as I can condense it to. Any questions on expanding and condensing? Yes, Caden.
Do you need parentheses around the log?
Around the log here?
Yeah.
No. The only time we use parentheses is, like we used it on this problem, because I know I want to make sure that x and y are on top of my division, or things like that. Like, when we expanded it, if we were to condense this back down, we would want to make sure we multiplied 3 times x before we turn this into division. That's when we use our parentheses. Alright? Great question. Any other questions? Alright, we have about 10-ish minutes. Do we want to try those you-try problems?
No.
Or do you want to hand out the homework?
Homework.
Homework? Alright, here's the deal. I'll put the you-try answers up after I hand out the homework. And if you want to try them, you can. Actually, I'll put them up now. Alright. Yo, are there? Let's see now. Oh my goodness. Alright. So, all it wants us to do is use the properties of logarithms to evaluate these expressions, to make it easier. Thank you for making me notice there's more notes. So, here's the deal. You can use the properties to separate these, make it easier for you to do. But a lot of them you can just plug right in your calculator, right? Now, the first one, I have multiplication. I could separate it to log base 2 of 4 plus log base 2 of 8. And I could plug those separately into my calculator. To do them, I would get 2 plus 3 gives me 5. Right? Log base 2 of 4 is 2. Log base 2 of 8 is 3. Add them together, I get 5. Or, realistically, guys, you could just do 8 times 4 and do log base 2 of 32. Now, that wouldn't work for what we're teaching you today, but on a test, that'd be perfectly acceptable. Alright? So let's look at the next one. B, the natural log of e cubed. How could I change that one? Well, do I have multiplication or division? No. Do I have an exponent? Yeah, so I can take my exponent, put it out front. 3 times the natural log of e. The natural log of e is 1. It is always 1. So then you would get 3 times 1 equals 3. So there are ways to make these things easier on you, putting them in your calculator or doing them by hand. But you don't necessarily need to do all of them. Like the next one, you could put in log base 2 of 64 in your calculator, that'd be perfectly fine. Or you could do 2 times log base 2 of 8. Log base 2 of 8 we said was 3. 2 times 3 gives me 6. Alright, so it's only using those properties we know that we just learned to evaluate these expressions. Alright? Are there any questions on that? Do I need to go through the final 4? No? We're good? Everyone's good? Good? Joseph, good? Good, fellas? Any questions? Alright, then I'll finish handing out the homework.
Okay.